Hey, good evening, guys. Mr. Collison coming at you again here. New video for you guys. We're going to start working on trying to understand some basic chemistry things. Before we get there, just a couple things I want to make sure I do mention. Um, Last week, we spent the majority of our time on plants. I hope that went okay for you guys. I hope you guys were able to get some of the stuff that I wanted you to be able to get from the videos. In all honesty, guys, plants are pretty basic. There's not a lot of stuff that we really need to know about them other than the fact that they use the byproducts we give off, which is carbon dioxide, to make oxygen, which is something that we need. So that process of photosynthesis is kind of what's going to be driving this week's lesson of stuff, and that's going to be this basic chemistry stuff that we're going to start with here today. Do make sure that you guys are getting your work done. We've only got just a couple weeks of school left. I'm assuming, if everything goes to plan, we're going to be done with school on the 20th of May. I know we're doing the distance learning all the way through there. And I believe we've been asked to make sure that all assignments have been turned in and completed by the 15th of May, which is going to be not this coming Friday, but the next Friday after that. So make sure you guys are getting your work done. Make sure you guys get stuff handed in so that you guys can get the credit that we can get for you, okay? All right, let's go ahead and get started here. We're going to start with some basic chemistry stuff today. I'm going to try to keep it pretty simple. What I can tell you is that we don't spend a lot of time studying chemistry in life science because there's just not a lot of stuff that's kind of going on there. But what happens is when we get to talking about plants, we have to understand what's going on behind the scenes in order to know exactly what the plants are doing for us. So that's where this basic chemistry stuff's going to come in. And I'm going to kind of walk you guys through a little bit today just on some of the basic notes that I want you guys to take. I'm going to try a couple things. I'm going to do a little screen sharing with you guys here in just a little bit. You'll just have to kind of bear with me as I kind of navigate through that. But before we begin, the one thing I want to make sure that you guys are really, really, really clear on and understanding is that you are going to be needing a periodic table of elements for this week. Okay, so you guys can go online. You can just type in periodic table of elements and you can find something that looks like this. Now, the colors and stuff, I don't care about that. What I'm more concerned with is, do we have this table so that we can look at the basic elements that are going to make up each and every part of this? That's why you're going to need the periodic table. So make sure that you guys find one online. Use your agendas if you need to. I believe there's one in there if you really, really get desperate, okay? All right, here we go. We're gonna get started with some basic chemistry notes. And what I'm gonna do is I'm gonna share the screen here. I'm gonna go through a couple little parts with you guys to make sure that you understand what it is I want you guys to know. So here we go. We're gonna try this out. We're going to share the screen with a PowerPoint presentation that coincidentally I also have attached to your guys' assignment for today. I'm going to make this a little bigger. Okay, so guys, this is the PowerPoint presentation that I have. It's called Balancing Chemical Equations. But really what this is going to be about, guys, is understanding what's going on behind the scenes, okay, when it comes to this photosynthesis process. And then after we get done with some of the basic stuff here, we're going to start rolling into balancing these chemical equations. I'm going to show you guys how to do that using the exact same PowerPoint that I have here. Okay. All right. I'm going to scroll down because the very first thing that I want you guys to understand here is this is my main objectives for you guys. Okay. Number one, I want you guys to learn how to balance these chemical equations. Honestly, it's a really hard concept because for a lot of us, it's trying to put together both science and math. And even though they go together really well, this is a concept that's really hard to understand, okay? What I also am gonna need you guys to do here is you guys are gonna have to take notes any way, any shape, form that you guys think is going to be best for you, okay? It's gonna be up to you guys. I don't have a note sheet for you. I don't have anything like that. You guys are gonna have to take the notes that you guys need, okay? All right, let's get started because this is going to be the very first thing you're going to want to make sure that you always remember. In chemistry, there is a law, and this law can never, ever be broken. So when we take this chemistry and we move it into the life science realm, you guys have to adhere to this rule, okay? It is called the law of conservation of mass, okay? So let me jot that down. Law of conservation. And I'm going to change the word mass here. I'm going to use the word matter instead. It doesn't change the definition. It just simply it's just going to change the wording of it a little bit. That's it. It's nothing else. Everything is still the same, okay? Law of conservation of matter. And what we're going to have to remember about this particular law is that in a chemical reaction, which photosynthesis is, we can't create or destroy anything, okay? So what this is basically going to say is that matter cannot be created or destroyed in a chemical reaction. Okay. Okay, here's really what it boils down to, guys. Whatever things we start this whole reaction with, they're still going to be there at the end. They're just going to change the way that they look. Okay, and I'm hoping that as we kind of work through this, I'm going to be able to show you guys that. Okay, and hopefully you guys are going to be able to understand this. But basically what it comes down to is this, guys. We're going to be working with individual elements, and these elements are made up of atoms. Atoms are going to be the itty bitty little things that are composed of the protons, which are a positive part of this, the electrons, which are a negative part, and the neutrons, which are a neutral charge. So basically, a neutron is just mass. So one of the things that you'll notice about the periodic table, and I'm going to go ahead and pop this up here. Okay, this little box right here, this is the key that you guys are going to be using when you look at the periodic table. This is the element oxygen, as you guys can see. So what we've got here is we've got a whole bunch of numbers and we've got some letters. Okay, I'll get a little bit closer here. All right, let's make this very simple. Okay, the topmost number, this little number 8 that's up here, that's called the atomic number. And what the atomic number is always going to do is it's going to tell us the number of protons that are going to be found within this element. Now, the awesome thing about this is however many protons we have the same number of electrons. So if oxygen has 8 protons in this element, there is going to be 8 electrons floating around outside this thing as well. Okay, so let's start with our next little note here. And I'll erase some stuff. You guys can go back and watch the video, get whatever you need, okay? The atomic number is equal to the number of protons and thus electrons of that element, okay? So that might be a little confusing for some people, but basically here's what it comes down to, guys. When we see that number 8 for oxygen, it tells us that there are 8 protons in the nucleus, in the center of that element, and then around it, floating around it, are going to be 8 electrons. Okay, I'm not going to get any more difficult than that. We're going to keep it pretty basic. The big O, that's just a symbol. Okay, it just helps us understand what element it is. O is oxygen. You'll notice that there's all kinds of different ones. There's hundreds of them on that chart. Here's the name. Right down here, though, this number that's got all kinds of extra spots to it, like 15.999, guys, those decimal numbers, that is the atomic mass, okay? And basically what it comes down to is that is the number of protons and the number of neutrons that make up that element. Now, the easiest way to understand this, guys, is we don't have to try to figure out that there are 7.999 neutrons in this element. We round that number to the nearest whole number. So we'd round it to 16. So what that is telling us is that there are going to be 8 protons and 8 neutrons within that particular element. Now, those numbers always aren't going to be the same. Okay, sometimes we're going to get elements that have more neutrons, but remember that neutrons are neutral. They don't have a charge. It all comes down to the electrical charge on these things. It has to equal the positives, the positives have to equal the negatives. That's why we have 8 protons and 8 electrons when it comes to oxygen. Wow, that's a lot, isn't it? Okay. I'll just add one more thing here. Let's talk about that atomic mass. That atomic mass is simply equal to the number of protons plus neutrons. Okay, now guys, in reality, are we really going to need to know some of this stuff? Not really, but it is at least something to help us refresh a little bit. What we're going to really focus on is making sure we understand where to find the elements on that periodic table, and then how we have to balance them in order to not go against this law of conservation of mass or matter that we just talked about right up here. Okay. All right. Next up, I'm gonna erase a couple things because I don't have a ton of space here. So if you guys need anything, obviously go back, watch the video. You can pause it at any time. Get the stuff that you're going to need. Okay. All right. I'm gonna leave up the law of conservation of matter because this next part is going to be really important. When we balance a chemical equation, we have to break it down into two separate parts. On the left-hand side, we are going to have something that are called reactants. Okay? The way I always remembered reactants, these are the ingredients that we're mixing together in order to get something over here at the end part. So one of the things I'm going to add here is this word, ingredients. Okay. Now what you're also going to see, guys, is in between here, and I'll use a different color to help this. We don't use equal signs when it comes to these chemical reactions. Instead, we use an arrow, and that arrow is typically always going to point to the right. And what that means, guys, is that we are going to have a change of some kind. All of the things that we have over here that we're mixing together, they're going to change when they go over to this side of the equation. And when we go over to that side of the equation, guys, we're now not talking about reactants anymore. We're talking about products. So one of the things you're going to hear me talk about a lot this week is you're going to hear me talk about reactants and products. The reactants are the things that we mix up. That is what starts this chemical reaction. The products are then going to be the things that we end up having at the end. Okay. Now, I don't remember if I have a slide here. Right there. That one might work a little bit. Now, this one, obviously, guys, is saying that there's two reactants working together to make a product. That's fine. We can have more than one reactant. As you're going to find when we balance some of these, we're going to have two, maybe even three things that we're going to put together in order to get that product at the end. Okay, I think I got another one here. Here's where we talk a little bit about that use of the arrow. Okay, so we use the arrow instead of the equals. The arrow simply means or indicates that there's a change that has occurred. Okay, now this is some basic stuff. Okay, I know some of you are looking at this and you're going, oh, wow, I can't do this. And I'm going to go ahead and stop my share here because I want to be able to see you guys a little bit closer. All right, there we go. Guys, don't panic, okay? We're going to try to work through this just step by step. Try to help out and make sure you guys understand it to the best that you can because, guys, one of the things is we got to know how to balance this in order to understand that process. Photosynthesis is a lot more complex than just saying, oh, we take A and B and we get C out of it. Yeah, guys, it's way more difficult than that. And that's why we're going to spend some time with the basic chemistry stuff, okay? If you have any questions, make sure you hit me up with an email. If you guys still want to do any Zooming, honestly, guys, I haven't had anybody take me up on that offer. If you want to Zoom and do something face-to-face, send me an email, send me a message through Google Classroom, and I will get something set up so that you guys can come on and we can do stuff, okay? My office hours are still 9 to 10 and 12 to 1. I am available pretty much at all times through during that time. I'm also usually available throughout the day because, guys, I have my phone. It's synced right up to my email, so I get those things from you, okay? So make sure you guys hit me up if you have questions. Hopefully this wasn't too much to start you guys off with, but we're going to go ahead and end our note session right now, and we're going to get started on some balancing equations in a little bit. See you soon.